All right. Good morning, everyone. Are you all ready? I'm on my first coffee still, so whatever I say that doesn't make sense, it happens. So you're here this morning to hear about the Edge Computing Group, Edge Computing Working Group update. If it's not what you wanted to hear this morning, then you're probably in the wrong room. Those of you who are in the right room, still seats in the front, feel free to come closer. And we like to do our panel sessions in a way that like to have the audience get involved and ask questions or add comments. There's a microphone in the middle of the room. We also have a lot of mics, so we can always donate some to you if there would be multiple people trying to shout things at us. So that's about it for logistics. And who you have here this morning, when it comes to, all right, little background info just while everyone is waking up. We delivered a similar panel to this one at the Open Networking Summit, and getting inspired by Ian, who will introduce himself soon, who doesn't really like wearing shoes. This is how it kind of became the shoeless panel. My shoes are really uncomfortable, so I don't want to stand 40 minutes in them. And the rest of the people, they just like to be comfy. So this is the cozy, nice panel. We are inclusive to everyone, whether or not you're wearing shoes. So, introduction part. I myself, I'm Iliko Bancha, working for the OpenStack Foundation. I'm doing a lot of things, but the relevant items from those are, I'm one of the co-leaders of this working group, and I'm also doing community management activities for StarlingX. If you don't know what StarlingX is, look up the project update and project onboarding sessions on the schedule and attend them. And with that, I will let the panelists introduce themselves, and then we will dive in.
So I'll start. I'm at the far end. My name's Chris Price. My picture is a little dated, as you might tell. I promise I will have an angry beard face picture next time I have on the panel. I work with Ericsson, working with the open source division there. And we are doing a lot of work on edge technologies, how to modernize the edge, how that works when you go from very far edge devices to central office type environments back to public clouds, and how to interwork with those types of technologies.
So I'm Beth Cohen from Verizon, and we're probably one of the few companies that actually has an edge product that's in production, and we're selling to customers, and we've actually stood them up, and they're using them. So I've been involved in the Edge working group since its beginning, one of the founders, and my contribution is all the pain around tooling and operational support. So that's my interest in being part of this panel, or part of this group.
Hi, my name is Gergely Csatari. I'm working for Nokia in the Open Source Program Office. Inside that group, my responsibilities are clouds and containers. So this is why I'm interested in Edge, because that's like the next step for all of these things. In the Edge Computing Group, I was working on the requirement analysis phase and like managing the whole thing somehow.
Hi, I'm Ian Wells. I'm from Cisco. I work on Edge. You'd be amazed to hear. And yes, I've been working on mobile Edge in recent times, doing Cloud RAN, which is basically the radio access network at the very edge of a mobile service provider's network. And we've been doing platforms for that, trying to get the whole thing effectively to hang together and not fail in the middle of your important phone calls. So we've been doing the practical experience of Edge in this, I think. I'll come and join these guys for a panel. I have to admit I don't attend the Edge working group sessions perhaps as often as I should do. So I'll sit here and tell them they've got it all wrong.
As you can see, like, we accept all sorts of contributions, so you can come and sit with us on a panel next time if you would like to. So before we go into the question-answer part, is there anyone here who has no idea what this group is doing, never heard of it? Everybody knows the group?
Okay, I'll say I don't know what you're doing. Tell me.
Good. Then I will go through this. And those of you who were too shy to admit, then you will benefit from that as well. So this working group is a little bit of an odd one out. It's an OpenStack Foundation level working group. And as the name says, we are focusing on edge computing, but basically on a higher level than the OpenStack Foundation projects. So we are looking into use cases, identifying requirements, defining reference architectures, and working together with both OpenStack Foundation projects and other communities and projects in the open source ecosystem to have the gaps addressed and all the requirements fulfilled. So when all y'all who are trying to roll out the next generation of edge computing use cases, new business items, then you can succeed and you have options to pick open source solutions for it, and you're not limited to proprietary solutions only. The working group has a focus on the infrastructure as a service layer components, but we do not have any limitation on industry segments. So at this point, obviously, our discussions are more like telecommunications and network heavy because, as like Beth said, this is where the action is already happening and where the new systems are rolled out at this point. But we are also looking into all other things that are popping up, like industry, like factory automation, automotive, and healthcare, basically any use case that has something to do with edge computing, we are interested in it. We will not sort out the whole stack. We will work with other communities in the ecosystem to figure out the whole big picture. So as I said, infrastructure focus is what we are doing. We have a white paper. You will find a link in the slides that will be posted online, or just take a photo of it now. That's basically kind of talking about setting some common, or well, the base ground of our work and some of the terms that we are using. So it's a short, nice read if you're interested in checking that one out. Anything that I left out that someone would like to add? No, everyone's happy.
No. So I want to add that one of the reasons that the Edge Working Group has been was even created is because what we found is that Edge is a superset of cloud, and it has a lot of nuances and complexities that people that have been working in cloud for a long time didn't really think about. So that's been one of the interesting challenges of being part of this group and also being working in the Edge environment.
Thanks. I switched over to the mission statement. Do you want to say a few words about it?
Oh yeah, sure.
Because it's your fault.
It's great when you wake up at 3 o'clock in the morning and it just pops into your head, which is what this did. So this is a draft group mission statement. So we'd been talking about for a while that the group's been working for, I guess, about 2.5 years now. And I think over time, these types of groups tend to change as technology moves on and issues are resolved and new issues come up. So we decided it was time to create a mission statement, and this is our first draft. We will be having a forum session later on this afternoon to hash it out. So I encourage everybody. Kind of the point of this forum is, or this panel, is to encourage everybody to come to the 3 forums that are happening this afternoon to really work on what the next steps are for the Edge Working Group and what Edge needs to be. It's your time to contribute. So this statement is, defines it fairly broadly, and I did that on purpose, and then follows with an objective, which is also fairly broad as well. So come to the forum later on, and we can argue about it.
Thanks. All right, if anyone has any questions, whenever it pops into your mind, just grab the microphone in the middle of the room and ask us. Don't wait until the, I don't know, second half or end of the session. So with that, Beth mentioned forum sessions. We will have reference architecture discussions, use case discussions, roadmap discussions. So it's all happening today on this floor somewhere. So look it up on the schedule if you're interested in any of the discussions. And a few more links in the slides.
You should also mention the PTG sessions as well.
Yes. We have a PTG project teams gathering starting on Thursday. The Edge working group is meeting Thursday morning, and there's also 1.5 days for Starting X, which is another Edge-related project under the OpenStack Foundation umbrella. So if you're interested in participating in that and you have questions, find me after the session, and I'll help you figure out the details how you can attend. All right. And with that, let's jump into some of the more meaty part of the discussion. So anyone would like to take a stab on like what we've been working on since the last update and how we are progressing and what's happening?
Yeah, let me take this MVP reference architectures part. So this is one thing what we are working on. So this is basically like a set of architecture options, how you can organize your OpenStack services to get edge cloud infrastructures, and we are working on two kind of architectures, which is the centralized control plane, distributed control plane, and we know that these are not perfect, and we know that there are other alternatives also. It's just we do not have the input for the ones who know that there are other alternatives.
Is it time we give our input?
Yeah, although before I'd like to give a shout out to James Pramick, who's right there, who was responsible for these working on these. So, thank you. So yes.
Right, because I mean, as we've been doing this, then these architectures basically separate the components. But one of the things that we found that worked for us is trying to make your edge as autonomous as possible, a little bit more like a router, which you know, fine. It's got its control plane built in. It talks to its neighbors, but if it's not talking to its neighbors, it still gets its job done in the meantime. So we tend to go for autonomy when we're doing designs ourselves.
Yeah, I think these are the two big options, but we will have a forum session about this today where we can have a more detailed discussion.
I think autonomy was one of the topics which was hot when we ran the PTG sessions previously. And I think for those that aren't really familiar with how they went, we talked about how do you have autonomous sites, how do you make sure that if you lose connection, that when it comes back up, you can still maintain connection. We talked about how you do access control at different sites and how you do image management at different sites. And so there's been some work done in Keystone for federation models. There's been some work done in Glance for how you do image management in secure and less secure environments. And that work has been ongoing and is continuing to develop, and the testing and deployment activities are ongoing. And I think these reference architectures have provided us with a footprint on really addressing one of the hot topics, and that was how do we get to select which services we run where. And that was something which was really key to us when it comes to Edge. We didn't necessarily want to carry an entire OpenStack, everything to everywhere. So we want to be able to isolate and separate different services. And this was really just a way of exploring how that looks. If I have a small edge and I don't necessarily want too much autonomy there, aside from the autonomy of the workloads that are running, we don't necessarily want operational autonomy, then you can take the centralized control plane approach. If you still want operational autonomy, you may look at distributing the control plane more concisely in the different locations. So there is a long, detailed history behind how we got here, and it is a work in progress, and we are still learning as we go, as we try these services out in different ways and understand how they behave when you run them in different contexts.
Okay.
Okay, yeah, I'll talk. So, yeah. Oh my God. Yeah, I think basically, although this is a good start, it clearly is not the end game. And as we've dug into Edge, and certainly as you know, I've been part of the rollout of an actual product, we're finding that these are just too simplistic to really handle the the true complexity of actually managing an edge environment. So I look forward to more detail and really a dive into where the components really need to sit, because I think it's a continuum. It's not just a centralized or distributed. I think it's both, because you want to put the components in the proper place in the overall environment to make it all work. And that's going to vary by use case. So an IoT gateway is going to have a different characteristics than a virtualized networks, distributed network services. So that's one of the places that I think that there's a gap that we need to fill from this group.
I think one of the other things which is kind of a phase two. So you'll notice we have Nova all the way up to the edge, and there's a good reason for that, because it works. And we've been talking a lot about, okay, when you get to the small edge, we're probably running Ironic there, and we're probably using Ironic, and we may not have Nova on some sites. From an infrastructure as a service layer, I'll be running containers ubiquitously across this. I mean, if I'm running a service layer, I'll run it in containers because it's just easy to manage. But from an infrastructure as a service layer, we may be using Ironic at the edge, and there's been a lot of work done in Ironic. We're probably approaching the point now where we can start to develop and identify how these distributed solutions look using Ironic now. But it has been a work in progress, and it is a procession. It's not like you snap your fingers and a bunch of code is written by people. We have to work through this and test it and verify it as we go. And containers is very, very interesting. I mean, container federation is a topic which is very interesting to me. I don't know if anyone's using Federation 2.0 from Kubernetes, but about 3 weeks ago you could do Federation 2.0 with more than a single node pod, which is great because then you can actually start to do interesting things. But that's coming along as well, and it's starting to achieve a level of maturity where you can start to play with it in these types of environments and understand how it works within the context of a distributed system. Ian can probably talk lots more about that than me.
Well, this is an interesting question because there are certain things you want your edges to have in common. So it's reasonable to say you'd like your identity in the edge to be a common feature, as in if I'm allowed to run things, I'm allowed to run things either everywhere or in a wide swathe of the edge locations that I've got, because it's not an end user thing, it's to do with the applications you're running and where they're authorized to run. Which is usually an automated thing as it comes out anyway. So federation of identity makes a great deal of sense. But on the other hand, there are very few use cases in nearly every edge use case that you're looking at where I've got this workload and I really don't care where it runs, because in actual fact, I care very much where it runs. I wouldn't be doing edge if I didn't care where it runs. I'd just run it in the center of my network. So as far as workload placement goes, then federation or consolidation of the network of the system is a lot less interesting. So it's not a straightforward question of does federation work. It's a question of what you're trying to do here. But my take is that what we're trying to do on edge, and again, you can see the driver in this architecture, is edges are small, usually, but edges are lots of. There are many of them, which means if I'm running 1,000 or 5,000 or 10,000 of these sites, then every CPU cycle I waste on doing management, every CPU cycle or every disk I waste on storing images that don't need to live there all the time, every bit of that is added cost that gets multiplied up 10,000 times. So mostly what it comes down to here is, these are architectures, these are the results of a process, but the input to the process is, how do I make this actually affordable? How can I make this work?
I think it's also very important to state that every management operation where you don't waste CPU cycles will cost more. So if you do not automate everything which is related to the management of these, then this will just not work.
Yeah, we think computers are expensive, but actually people are expensive. If I'm running 10,000 edge sites and I need 10,000 people to look after it, that isn't going to work. If I'm running 10,000 edge sites and I need 10 people to look after it, then people are going to pat me on the back and pay me a bonus, so that's great.
Yes.
So on that exact topic, what kind of new tooling is coming around to ensure that we can actually operationalize this? Sorry, it's a little close. So installing OpenStack, that was 90% of everybody's focus for the first 5 years when it moved out of NASA and CERN and all these other places. We're this is really, really hard to set up. And now you're saying we're going to set up 10,000 of these sites. So what standardized tooling is going to pop up within the foundation that allows us to do this at scale?
I can start. I mean, take a look what AT&T have done bringing Airship. It's Git managed site control. I mean, it allows you to do lifecycle management. It's probably not the final answer. In fact, I would even assert, hopefully no one from AT&T, it's not yet the final answer. But it's a step in the right direction. I mean, you know, version controlled site management, minimizing, having a system where people are not allowed to touch a site unless something breaks is the first and best starting point, because as soon as someone touches something, someone else doesn't know what's happened. So being able to version control what's happening, being able to automate site upgrades, the types of things Airship is bringing, extremely important in my mind.
Yeah, I want you to think in terms of not networks for a second or clouds, but actually Windows laptops. Because every company has thousands of Windows laptops, and you will almost never have anyone log into your Windows laptop to do anything. That whole process of, you know, birth to death of your laptop has been automated because they simply can't afford, again, to have, you know, one person supervising your laptop, although in your case it probably needs one person supervising your laptop. But you know, this isn't a problem we haven't seen before, but you have to think in terms of that laptop, what they're doing, right? They're making sure that the moment it's installed in one way, and then it's given to you and it's brought into the management system. In Edge, that's probably two operations combined into one. There's no reason to do them separately. But it's also installed by you, not the administrator of the network. So we've got to work out how to deal with that. And then from there on, it's lifecycle managed, it's version controlled. There are occasional checks to make sure you're not doing anything unfortunate with it, and so on and so forth. These are the kind of operations that we have to remember when we're doing Edge sites of any variety.
Yeah, let me add that you're absolutely right. The installation is just one component. In fact, actually, I would argue that it's probably the least component, because the operational life cycle is actually much more important. You know, yeah, okay, I think that's probably the easiest problem to solve. You can slam a, you know, whatever, you know, environment onto a box, but then you have to manage it, then you have to upgrade it, then you have to make sure that it's working, then you have to replace it if it doesn't work, and when it's located in the North Pole, that's a little difficult. So there's a whole lot of other considerations that are probably 90% of the problem.
Verizon 5G at the North Pole. Woo!
Yeah.
I just would like to add that Airship is one of the projects that's looking into the deployment and lifecycle management parts. There's also Starling X, which is an integrated edge platform, and among the questions what the reference architecture work in the working group is trying to answer, they're also looking into how the operation side of the things will work, like configuration, host, service management, how that all will be handled. I saw a few people from the Starling X community here. If anyone wants to add more detailed comments to this, I'm happy to lend over the mic. But basically, that's another project where some tooling is getting there. On one hand, they are integrating a few components from Airship on the deployment side, and there are also some new components designed and developed in Starling X for the operational sites parts, looking into zero-touch provisioning and all these kind of new, shiny buzzwords that are popping up these days.
Which leads us to the next slides, right?
Sorry, I just wanted to ask one follow-up.
Oh, he has one close.
Flick it up. There's a switch.
Switch it on and wait for.
If you mind,
3
Mark,
seconds while
I'll
it
ask the question by
boots.
reading your lips.
I'll just come on up here then. Oh, perfect. Thanks, Ildiko. So going along the sort of scale side of things, one thing that struck me a while ago was, okay, we've got these tens of thousands of nodes out there, and we're talking about lifecycle management, but what about firmware? Say another thing like the Spectre meltdown comes. How are we, or what in this community, in this working group, have you seen and are looking at addressing that sort of scenario? So.
Until now, we did not address this scenario. We were just starting to think that maybe this hardware management might be a problem, but we did not. we did not went after it and figured it out yet. but we need to do it, yeah.
I think it's
ironic and airship into this portfolio of the edge.
yeah.
Yeah.
I mean, it's not just relevant from a firmware perspective. You've got to worry about your BIOS, but practically speaking, your BIOS doesn't run for very long on the host. But a lot of the out-of-band management that you'd use Redfish or IPMI to deal with, there are certainly configuration options. And here I'm speaking NFV, and with apologies, right? I know there are a lot of edge use cases, but NFV is performance evil, basically. You've got to accept that. And what we find in NFV use cases is that dealing with things like clock speed adjustments, which Intel will happily do for us without asking permission sometimes. Those sort of things. If you don't get your out-of-band settings correct, then you don't get consistent performance. And that's true for a lot of things. Again, in certain circumstances, power management can be a concern, so effectively running appropriate power management controls is necessary. And without consistent BIOS settings, then you don't get that. Again, 10,000 sites. I keep saying that number, and it sounds fantastical, but I mean, 2,000 to 4,000 is what we were talking about. Yes, and sometimes it sounds fantastical in the other direction. But if they don't run exactly the same, you can't look after that. If they run exactly the same, they all fail. I hate to say this, but they do. They all fail in the same way, and they're predictable. And if you need to put a fix on one, you need to put a fix on all of them. But if they're different in any way, shape, or form in their behavior, and the out-of-band management and the BIOS version and the rest of it all matters to that, then you can't administer that network. It doesn't work.
Yeah, I think that it's also, there is a question.
So your description of the laptops and how people manage it, that is edge computing right there.
Yeah.
Every company already has
Yep.
it.
Yep.
Absolutely.
So is anybody looking at that, at the best practices to pull that in? Because every company's already doing that. And it seems like everybody here is like, let's reinvent the wheel and figure out how to manage hardware again. It's like, we're already doing that with laptops.
We're already doing that with hundreds of thousands of cell sites. I mean, it's nothing new. What we're trying to find is common mechanisms that allow us to have common behaviors for operators to work, not just with Ericsson systems, but so that we can have a ubiquity of practice that applies to anyone that wants to start to work and engage in this environment. So I'm not trying to reinvent the wheel, just trying to find a wheel that kind of looks the same or same enough for everyone, I think is really the plan.
Yeah, so there is one difference between the laptop example and the cell sites example, which is that, and the routers example for that matter. Most of the operators are used to the concept of an appliance, because a laptop, at the end of the day, is an appliance. So it's a piece of hardware that has a single purpose. So the big change with edge computing is we're talking about hardware and systems at the edge that aren't necessarily single purpose anymore. And that really rips open all the tools that have been built to serve single purpose appliances and makes them not work very well.
You see, I wonder about that, because if you define the purpose as basically running applications, which is what you do for a laptop, then this is pretty similar.
Maybe
I
that
think
is
one
the
thing
way
that
to
does
do it.
vary between this and laptops is your corporate laptop, if you're lucky, you get a choice of about 5 models. Very lucky.
5?
Yeah, exactly. If you're really lucky, they actually come from sometime this century as well, which is kind of nice. But again, that point about Edge being so widely deployed, what happens is you tend to end up with oddly customized edge for the use case. I know we shouldn't do this. We all agree that cloud is supposed to be general purpose, but practically speaking, you have to find a balance here between the cost of the thing that you're putting out there and the purpose it's intended to serve. You're not going to put an extra 10 hosts in 10,000 sites, just in case. So that cost tuning means these things are sometimes, they're not snowflakes, but you sometimes got a variety of things to deploy. So it's not identical hardware in the same sense.
Yeah, I was going to make the same point. I mean, especially when it comes to the hardware resources, and back to Mark's question, we find the best common practices, the best common use cases, but maybe a cell site isn't a great example of a common use case that's going to be used. So what we try and do is focus on, okay, let's try and expose a common set of infrastructure. So we look at the infrastructure as a service layer as a great place to try and coalesce around best practices so that we can work with general equipment practices for the data center space, but also allow integration points to specialized hardware that then allow that hardware to expose a common infrastructure as a service layer to run your applications and workloads. So it's just, I think the focus here is on being able to expose heterogeneity into a common deployment model.
Yeah, heterogeneity with a single interface. Totally simple. We'll just go home now, we're done. It's good.
Yeah. What could be similar?
One other thing what I wanted to add based on the questions or statements, so it's not 5 of us who will figure this out. So if you have any ideas, what should we look after, or you have any ideas how to solve these problems, just first of all visit the forums and then join to the weekly calls and contribute to the group's work.
Hi, I'm Rob Hirschfeld. Yeah, I don't even know where to start on the hardware stuff because I think most people don't understand the actual complexity of physical layer infrastructure, even down to the type of storage medium and type of BIOS and the boot processes and things like that, and how it actually really significantly matters. Which leads me to what my actual question is. How do you comprehend the cost of complexity in these architectures? Because I hear us running to adding things in and adding things that are very complex. And 10,000 of something, it's an exponential complexity has exponential cost in these models. And so I'm interested in hearing not just what we're throwing into the pot, but what we're taking out of the pot.
Ian.
Oh, it's my turn. That's not fair. Right, so, yeah, I think that's a very good question. If we look at our friend the Etsy diagram, which haunts my dreams, I would like to point out, it's complex. It was laid down really before people tried it. I mean, it seems obvious to say this, but they were inventing NFV at the time, so they basically drew this and they said, right, well, this will do. It looks a bit like what we used to do, and it looks a bit like clouds are in there, and it looks great. I think perhaps what we need to do here is we need to work out what to learn, right? If we're trying something and we think we're adding complexity, then the standing answer to, is this going to work, is why don't you give it a go and see if it works? But it doesn't mean to say that you settle on that as an answer. It means to say you learn from the experience and you fix things going forward. We need a bit more of an iterative process in that term. So, as you say, remove things that are not working for us.
I mean, it's exactly the right question to ask. You know, when we approached our cell side and edge team and said, hey, we're really interested in running, you know, open virtualization technologies on your sites, it took 15 minutes for them to stop laughing at me, to be honest. But then we tried, and then we found, okay, this is just a disaster. This is better. This is okay. And we really are looking at we're chasing the innovation cycle, as it were, trying to figure out, okay, these technologies seem to work better in these environments, and these technologies seem to work better in these environments. And I don't know enough about hardware to have an opinion, to be honest, as you rightly point out. But I got guys that do. It's really just about trial and error, and then it's about coming back and saying, okay, it is actually interesting to have this type of service here, and it's not working the way we need it to work today. And then we have to come back to these communities and contribute, or at least have a conversation around, is it possible to adjust them to fit in certain ways? And it's a long process. But what we're really trying to do is focus on what do we need in different parts of the network, and what are the tools that we have available, be it from CNCF or OpenStack or you know, Linux itself.
So I'm going to jump in and ask the panel a question, because I can do that. And you just threw me a ball, so I thought, fine, I'll do this. Because one other question here that comes up is, you know, in the laptop model, then the laptops, generally speaking, don't report that they're failing. You have users for that, which is maybe a bit evil, but it's a feedback mechanism. They'll tell you whether the hardware is failing because your keyboard's got a stuck key. They'll tell you whether the software is failing. They'll tell you when it's not failing, but they think it's failing, such is life. But I think to add to, you know, what Rob's saying is there's a lot of complexity in this from the hardware and the software and the application. How do you summarize what's going on so that when something is not working the way it should, how do you tell what you're going to do about it?
So let me talk about that, because that's something that we've been struggling with. because it's very important when you in an operational model, particularly a telco operational model, where the customer will tell you that it's failing, i.e. they'll say, oh, my network's not working. That's about the extent that they'll know. But we already know that, of course, because we have alarms as well. So we need to be able to have fairly sophisticated tools to say, oh, well, actually, the spot that's actually failing is X, and that we need to do something about that. Touching back on what Rob said, the hardware disaggregation is actually making it harder because traditionally, you know, the router fails. You know, the vendor is responsible for that appliance, right? So Cisco is responsible for the box and the software. So here we are disaggregating the hardware from the software and pushing the integration of the two back to the, in our case, the telecom, which is a company that may or may not be used to doing that. And so we're taking on something that we are traditionally have pushed back to the vendors. So that's actually one of the things that I'd say the working group has been struggling with, which is who's responsible for doing what?
I think, oh, well.
Right. Pieces, all open source, so go ahead. And at the end of the day, the customer experience was matter.
I mean, to the question, I don't subscribe to the viewpoint that because we have a virtualization layer, everything should be virtualized. And because we can disaggregate, we should disaggregate everything. If you have a specialized hardware that serves a specialized purpose, that has a specialized use case, and you have specialized software that runs that, it's probably going to do a pretty good job of it. The question is, and I think the real value that we have is, can we do more with the assets that we have out there? Not do we tear apart the assets that we have and make it hard to run them, but is there a way that we can bring things to those assets that allow others to then take advantage of them? And that's where I think the value is in what we're trying to do. Not necessarily tearing up everything that works and trying to make it work in a different way.
Yeah, I mean, coming back to the question, I think one thing is I feel you have an easier job than Beth, because when Beth's customers have a problem, they call her. When your customers have a problem, they can't call you because their mobile phones don't work.
They call us.
But it seems to me, again, coming back to the working group, this is a problem we should be addressing. It's not necessarily about pointing the finger at the specific component, because honestly, that's not what you immediately need to do for a repair. Usually when these repairs come up, they're urgent. So the question is, how do I do the right one? You know, the one that gets me working, and how do I get a post-mortem to figure out what just went wrong for later study? I don't need to know the source of the problem on the spot at the moment necessarily, but I do need, again, people to be able to call me and tell me their mobile phones weren't working.
Yes.
And so this goes also the operation again. So we should be able to monitor the behavior of the whole system, and we should be able to do it in some central place. I don't know how, but that's...
So I agree, but I mean, if I have, let's say I'm running a distributed network, I have 10 different edge flavors and 10 different vendors with 10 different hardware types and so on and so forth, and I want to run that in some sort of ubiquitous manner, and I have an infrastructure as a service layer that helps me, do I need to drive all 10 specific monitoring things up through that infrastructure as a service layer and try somehow make some big machine intelligence? I don't think so. I think I should be able to manage my infrastructure as an infrastructure asset, and I should be able to manage my infrastructure as a service layer as another network asset, and I should be able to identify and separate between the two in a meaningful way. Otherwise, I end up with a mess of metrics that I just can't manage anymore.
Yeah, I think, you know, effectively the cloud interface here is not saying all hardware is created equal. It's saying all hardware has common features. So we're saying here, well, I want to use cloud, I want to use a piece of hardware, and I want it to be a certain way. I want a certain generation of chip is a thing you can ask of OpenStack, to take an example. So it's not trying to basically make all hardware exactly the same, but it's trying to make the question you're asking answerable, almost. And it might well be here again that the information you get out of the hardware needs to have a common format, even if it tells you different things. But I think the bigger question here is not necessarily how do I get the information out of the infrastructure, but how do I correlate that with the application? Because practically speaking, and I'm looking at some of our service provider friends at the front here, nobody cares if the infrastructure is working or not working as much as they care about whether their application is working or not working. If the infrastructure is causing it, yeah, fine, they'll get angry. But the application is key. The application is what matters.
I was biting my tongue until you just hit the nail on the head. The question is whether or not you're willing to go ahead and maybe not standardize, but normalize. Whether we're talking about the operational data, like what sort of KPIs you're looking for, whether we're talking about, well, maybe we don't want to define the hardware, but here's a certain boundary, right, an achievable scope. If we look back to most folks in the room's competition 19 years ago, starting with DOCSIS and working their way up into OCAP, these exact same problems on scales of tens of millions are what the cable industry solved. Again, smaller problem set, same exact problems, and the willingness to trim it down a little bit, to normalize even when a standard per se wasn't possible, that willingness to say we need an achievable scope at every one of those layers, from the infrastructure up through the application platform and a few of the interfaces. The willingness to just trim it down a little bit is how that worked. But trying to boil the ocean, obviously, is unachievable.
Just a quick note that we are out of time, so last comment, note, and then we unfortunately have to evacuate the room. But I put up the forum session information, so if you're interested in discussing all these things forward, then please join us on these sessions.
Yeah, to piggyback up on his thing, and then I was leading with that first question to get you to talk about Airship and Starling X's. The one thing about the laptop example is IT locks you out of everything. They create like this semi-immutable configuration, and they put those guardrails that he was just talking about in place so that you can't, enable huge pages, but then not put, flavor size inside of your, VMs that you're trying to create. Like, they make these like repeatable bite-sized things. So whether I buy a Dell laptop or an HP laptop, IT can manage it the same. And you said it, right? One interface, but like all these different things. But if you don't get there, it's not going to work. If we don't have things like Git control, forcing the deployment and taking away, the operations folks aren't going to like it, but the ability for them to make, site A look slightly different than site B, then it's all going to fall apart.
I should also point out laptop management took about 15 years to perfect.
All right. Thank you, everyone, for coming.
Thank you.
Fun.